Hi everybody, this week we are going to be talking about truth tables and determining validity by creating these tables so that we can visualize whether or not arguments are going to be valid or invalid. And so remember, the reason that we're doing all of this is so that when our arguments become very complex, we will be able to break them up, we will symbolize the different propositions, the premises and conclusions, using the connectives, using variables, and then determine whether or not the arguments are valid or invalid based on placing them in this table and being able to see exactly where the premises will link up to the conclusion, or if in situations the premises do not infer the conclusion. And so with the truth functional character of complex propositions, we can use these truth tables to determine whether or not each complex proposition is true or false. So remember, when we're looking at the validity of an argument, the goal is to determine whether or not the premises are true and the conclusion can be false. If the premises are true and the conclusion can be false, then the argument is going to be invalid. The conclusion will not follow from the premises. So it's important for us to understand whether or not each proposition, premises and conclusion, are true in themselves. So we need to take these complex propositions and bring out the truth functional character of them in order to determine the truth and falsity of the premises and conclusion. That way we can know if the conclusion adequately follows from the premises or it doesn't. So in order to construct a truth table from complex propositions, the first thing we need to do is to set up reference columns. And what reference columns are going to do is they're going to explain all the states of affairs that could exist with every simple proposition as it relates to the complex proposition as a whole. So for instance, if we have a complex proposition made up of two parts, we would need to know whether or not each part is true or false, and how the truth and falsity of each part will determine the truth and falsity of the complex proposition as a whole. And we'll go over that in much more detail a little bit later. This is going to explain to us all of the states of affairs that could exist using these complex propositions. This means that we will be able to see whether or not the conclusion will fail to follow from the premises in any state of affairs that could exist using different truth values. So we think of essentially trying to create possible worlds where facts are true or false, different from how we think of them now, the same as how we think of them now, and put them all together to see that if any possible world the premises don't lead to the conclusion, then in every possible world, that argument is going to be invalid. That will show us, that will explain to us that the premises do not lead to the conclusion. So when we're creating these truth tables, we want to set up a reference column that will identify every simple proposition being expressed. Reference columns, you will have a reference column for each simple proposition. So here we have one simple proposition, Alex is sick. So there's one column. If there were two simple propositions, we would have two columns. If there were 3, 3, 4, and 4, and so on and so forth. But using only one simple proposition, we would know that there are two possible states of affairs that could exist. Either it's true that Alex is sick, or we're living in a world where it's false that Alex is sick. So with a simple proposition, our reference columns will only have two rows, rows being horizontal, columns being vertical. So with a simple proposition, you have one column and you have two rows, each expressing a different state of affairs that can exist. Again, if I were to express two simple propositions, we would have two columns. But with two simple propositions, there would be four different states of affairs that could exist. There would be four different combinations that we can make using the truth and falsity of these two simple propositions. So essentially, we're just taking the number of propositions, the number of simple propositions, and multiplying that to the power of 2, which means two simple propositions creates 4 rows. 3 simple propositions creates 8 rows. 4 simple propositions creates 16 rows, and so on and so forth. It's always the number of simple propositions to the power of 2 is how many rows you will get, because these will be expressing all the different combinations that can exist. So, with two simple propositions, Alex is sick and Alex is happy, we know we can have 4 combinations. We can be living in a world where it's true that Alex is sick and true that I'm still happy. It can be true that Alex is sick, but false that Alex is happy. It can be false that Alex is sick and true that Alex is happy, or it could be false that Alex is sick and false that Alex is happy. So here we are creating a situation that highlights all of the states of affairs that could exist. That way, when we determine the truth function of the complex proposition, we will know the truth of that complex proposition in each state of affairs that could exist. Once we draw up the reference columns, we are then able to incorporate the symbolic connective in order to determine the complex proposition's truth character. For instance, if we have two simple propositions, Alex is sick and Alex is happy, if we were to combine those two simple propositions into a complex proposition that is a conjunction, such that we're using an and, Alex is sick and happy, we would set up a third column for that complex proposition using the two simple propositioned reference columns. We can then determine the truth and falsity of the complex proposition. Here, with a conjunction, it's important to understand that conjunctions as complex propositions are only ever true when both the simpler propositions are true. So if you look on this table, we see that the complex proposition skull and crossbones and smiley face is true when skull and crossbones is true and when smiley face is true. When either one of these is false or both are false, then skull and crossbones and smiley face is false. Think to yourself about a situation where you've used the word and or used a conjunction. Tonight for dinner, we are going to have chicken and fish. That statement as a complex proposition would be false, it would be a lie, if you didn't have either one or the other or both. That statement would only be true if you had chicken and fish for dinner. So we know with a conjunction that conjunctions as a complex proposition are only true when what's on both sides of the conjunction connective is true. So let's go through all the different connectives and see how the complex proposition plays out based on the simpler proposition or propositions. When we use a negation, if I were to understand P as being the simple proposition, the phone is on the table, then if the phone is on the table, there would be a T. If the phone was not on the table, there would be an F. But the proposition that I want to know the truth character for is the phone is not on the table. So if I tell you the phone is not on the table, when it is on the table, that would be a lie. It would be false. So in the middle right box, we would get an F. But if I say that the phone is not on the table, in the state of affairs when the phone is not on the table, then I have uttered something true. So with a negation, we are essentially doing the opposite of the simple proposition within the reference column. Notice how the P in red is the reference column. It is expressing two different states of affairs because remember, a single proposition can only have two states of affairs, one in which it's true, one in which it's false. If I were to say it is not the case that P is true, then it would simply flip the truth value based on what the reference column expresses. For a conjunction, we've already seen this one. P represents the phone is on the table. Q represents the pen is on the table. Because there are two simple propositions, we know we have 4 rows, 4 possible states of affairs. And we're always going to lay out the reference column in the same way. We are essentially going to have half of the rows be true and false, and then we will do half of that true and false, and continually alternate the way down. This means that if you have 4 rows, we would have 2 true and 2 false in the first column, and then we would have true, false, false in the second column. If we were to have 3 simple propositions, which means 8 rows, then you'd have 4 trues in the first column and 4 Fs. And then you would half that and do 2 trues and 2 Fs, 2 trues and 2 Fs in the second column. And then half of 2 is 1, so we would alternate true, false, true, false, true, false, true, false down the third column. And you would continually do that same process no matter how many rows you have. It's always half true, half false. Then we will half that number depending on how many rows we have, and then we will half that number depending on how many rows we have, and we will half that number depending on how many rows we have, until we get to a situation where we are alternating true, false, all the way down. This ensures that we are acknowledging every state of affairs that could exist. By laying out our reference columns in this way, we are making sure that we do not miss out on a combination. Technically, you would be able to fill out the reference columns in any way that you'd like, but typically without the organization of going half and half, and then alternating half of that, and half of that, and half of that, and half of that, and then alternating 1, 1, 1, 1, 1, we may miss a combination. So it's always helpful to keep the same pattern all the time. Far left is half true, half false. Next column over, whatever that number of trues is, we're going to half that, and then we will do trues and then falses, trues and then falses until we get to the bottom. And then whatever the half of that is, we will do trues and falses going down as well. So with a conjunction, if I were to make the complex proposition, the phone and pen are on the table, as expressed before, this is only going to be true when both simple propositions are true. So in the top row, in row 1, we would see the complex proposition as being true. In each other row, the complex proposition is going to be false. Because essentially, if one component of a conjunction is false, then the complex proposition as a whole is going to be a lie. So our table for a conjunction will look like this. when it comes time for a disjunction is only ever false when both simple propositions are false. This means that if I use the complex proposition, the phone or the pen is on the table, then in row 1, when we see that P and Q are both true, we know our complex proposition as a whole is going to be true. In row 2, at least one of them is true, and because I'm using that or disjunction, then the complex proposition as a whole is going to be true. When the other is true, the complex proposition is still going to be true because of the disjunctive or. It's only in the bottom row, the 4th row, where the complex proposition is false. These tables are going to be important to memorize moving forward because these tables will express the truth and falsity of these complex propositions. Now with a conditional statement. A conditional statement is only ever false when the antecedent, here what comes before the arrow P, is true, and the consequent, what comes after the arrow Q, is false. So if I were to make the claim that if the phone is on the table, then the pen is on the table, that would be a true statement if both P and Q are true. It would also be a true statement if P is false and Q is true. Because think, if P is false and I'm providing a hypothetical if-then statement, if P is false, if the antecedent is false, then we don't necessarily need to get to Q in order for that statement to not be a lie. If I were to jokingly say, if San Diego State was the best school in the world, I would be the Queen of England, right? The truth of that statement relies on the fact that the antecedent is false. So that statement is true even though the antecedent is false, but the consequent is true. So in row 3, we would get true. Similarly, if the antecedent before the arrow is P and the consequent, if the antecedent before the arrow is false and the consequent after the arrow is false, it's still true. Because as I had just stated in the example, if San Diego State is the best school in the world, then I'm the Queen of England. Neither of those things are true, but it's still not a lie. I'm still not telling you a false statement. The only time a conditional complex proposition is ever false is when the antecedent is true and the consequent is false. Because when the antecedent is true and the consequent is false, I am then essentially saying that if this were true, and it is, then this other thing should be true, but it's not. So that would be a lie. That would be a false statement. So our conditional complex proposition table would look like this. For the biconditional is going to be true when what's on both sides of the biconditional are true, or when what's on both sides of the conditional are false. So essentially, when both sides are the same, a biconditional is true. So if I were to utter the biconditional complex proposition, the phone is on the table if and only if the pen is on the table. When both are on the table, it's true. When both are not on the table, it's also true. But when one is on the table and one is not on the table, then it's false. Same with the other way around. So this table would look like this. Biconditionals, remember, are similar to an equals sign. What we're saying is that one must exist with the other. One is both necessary and sufficient for the other, and the other is necessary and sufficient for the one, meaning they always have to appear together or always not appear together. So now that we've gone through these tables, we should understand how to set up the reference columns, and how to use those reference columns to determine the truth and value of a complex proposition. This is going to be important as we move forward, because when we start to create or start to determine the truth and falsity of complex propositions, we can then use those values to determine the truth and falsity of premises and the conclusion, and see whether or not the premises will lead to or not lead to a specific conclusion. So for the rest of the slides, we have the tables again as reference. Please make sure that you are memorizing these tables. They are important to know. More importantly, you should already know these inherently. You should know that if I told you that you're going to be eating fish and chicken for dinner, that you will be having both, and that I will have lied if you do not have one or neither. You should know that if I say, we're going to watch the baseball game or the basketball game tonight, that we will definitely be watching one or the other, if not both, but we will not be watching neither, because that would be a lie. So you want to make sure that you're memorizing these tables and understanding how complex propositions, how we can get a truth character from these complex propositions by referencing the simple propositions. Again, here is the negation, the conjunction, the disjunction, the biconditional, and the conditional. Now, it's important to note that with the conditional, that typically in logic, that we're not using a conditional as a causal conditional, but more as a material conditional. So when we see that the antecedent is false, but the consequent is true, we're not thinking of a cause and effect relationship necessarily. We're simply just connecting these things together in a material way. We're saying in a conditional statement that if the antecedent is true, the consequent will have to follow. And if that isn't the case, then that complex proposition is false. Again, as an example, I can make the statement, if Mesa is the best university in the world, then I'm the Pope. The implication obviously being that I'm not the Pope, therefore Mesa is not the best university in the world. This will be highlighted later on in the course when we start getting into types of deductive proofs, and we learn different ways in which we can deduce certain things from others, namely modus ponens and modus tollens arguments. But what's important about this particular conditional is that the conjunction remains true even though it's clearly not the case that Mesa being the best university in the world transforms me into being the Pope. Again, no cause and effect relationship. It's simply material where one appears when the other does. And when one doesn't appear, namely the consequent, the antecedent must not appear either.